I purchased a Ubiquiti E7 access point recently. I decided to work on two videos, one about the general discussions and the other one focusing on high availability. I'm going to release the second video regarding high availability first. Reason number one, I'm always intrigued by how high availability is implemented in a system. Second reason is there's zero documentation from Ubiquiti regarding E7 high availability. This is my lab environment. I have a E7 access point. In the setting, you can see for 6 GHz band, I set it to 320 channel width, the widest one. Then in Wi-Fi SSID setting, I defined one is only broadcasting using 6 GHz Wi-Fi band. Then from the lower part, the Windows machine, I already connected to the Wi-Fi 7 SSID, and you can see the link speed is very good, more than 5 gigabit each direction. And in the left side, in a Mac machine, is connected to a 10 gigabit switch. So I'm going to run a IPv3 server. Then I will do continuous speed testing just to simulate some load to the access point. Then we can look into the high availability implementation. As the first step, let's establish the baseline for the scenario that you do not have any redundancy. So you can see from the diagram, I connect the E7 to a UniFi switch, which has PoE++ support, and each part has 10 gigabit connection. I only connect the access point to this one single switch, so there's no any redundancy. Then from the Apple machine, let me start the IPv3 server. Okay, then from the right side Windows machine, let me run IPv3 client. The parameter I'm going to use is I will run it continuously. That's why I specify a -t. Server is the left side Mac machine. Then I will run 10 parallel connections just to add more loads to the access point. And I want to test both the sending and the receiving at the same time. So that's why I specify the bi-direction parameter. By the way, if you use the IPv3 client for Windows, it doesn't support bi-direction. So I'm running this particular IPv3 client in the Linux subsystem for Windows 11. Basically, it's a Debian Linux environment. So that's why I can specify the bi-direction parameter. Let me run it. Yeah. As you can see, for transmitting, it's about 2 gigabit per second, and for receiving, it's about 400 megabit per second. This is the performance I can get for this particular client, for this particular setup. Okay, I will keep it running. From the E7 insights, you can see the 6 GHz band is pretty much occupied. If I check the parent device, you can see it's connected to this 6-part 10 gigabit PoE switch, and the data connection is 10 gigabit, and the power consumption is 20 watt. Throughout this video, I'm not only going to check the data redundancy, but also the power redundancy. So keep in mind, when it comes to high availability for the E7 access point, it's not just about data. The power is very, very crucial as well. Now, without any redundancy, based on the current load, the power consumption is about 21.4 watt. So this is our baseline. Now we can start our HA discussion. On the product page for E7, Ubiquiti mentions it has 10 gigabit RJ45 port and 1 gigabit RJ45 port for power and data redundancy. Here, Ubiquiti uses the term high availability, mainly referring to the data and power redundancy. Don't confuse this with the normal high availability, which we understand, which is you have two E7 access points. They will be primary and secondary, or they will have load balancing, right? No, it's not referring to that case. It's only talking about data and power redundancy. if we check the installation guide, you can see it mentions A, B, C, 3 different options when it comes to data and power connections. So let's check option A first. It simply say you connect the 10 gigabit part for your regular connection, then the other one for high availability. For option B, it simply doesn't use the high availability. And then for option C, it will use the Wi-Fi mesh. Of course, you don't need the high availability when it comes to data, right? So basically, this installation guide doesn't provide any guidance when it comes to how to support high availability. That's the only documentation I can find from Ubiquiti. In fact, that's a trigger for me to work on this video. I really want to see how the HA works. So this is my setup for this video. I use 2 UniFi switches. The first one, we already saw it previously. It's a 6-part 10 gigabit switch. It's the previous generation of UniFi switches. At this moment, Ubiquiti doesn't have any other switch which supports both PoE++ and 10 gigabit yet. It seems their campus switch will support that, but it's not released yet. So that's why I'm using this switch for this video, right? And I use another switch, it's a Pro Max 24, to provide the 1 gigabit data connection for the high availability purpose. And then I still miss a power source for the redundant RJ45 part to provide PoE++ power supply, right? So to support that, I use a Ubiquiti PoE adapter. It supports PoE++, so that I can provide both PoE++ and 1 gigabit data. So this is the setup. Let me connect the left side green link. Then let's see when the system is in high availability setup, what's the data and the power situation. Okay, I have hooked up the cables for the redundant part. Now let me check the E7 information. Scroll down. You can see the high availability mode is active. Let's check the parent device. See, even though here the data connection it says is 10 gigabit, but the parent device it says is the Pro Max 24 switch, which doesn't make sense because I connect the cable to the 1 gigabit part of the Pro Max switch. So that's problem number 1. Problem number 2, see the power, it doesn't show anything. We have 2 puzzles to resolve. Let's start with the easy one, the power. So here, for whatever reason, Ubiquiti doesn't show the power consumption. It doesn't matter. I can go to the source to find it out. So then let me first check this 10 gigabit part connection. See what's the PoE++ power consumption. I go to the 6-part PoE switch. Then for the part 3, it is connected to E7. See what's the power consumption. It's 11.2 watt. Remember, before we connect the redundant power supply, what was the power consumption? It was 20 something, right? So now it's only showing half of the original power consumption, but you can see from the lower part of the screen, the iPerf 3 is still busy doing something, right? So it doesn't make sense. All of a sudden, the power consumption is only 50%. Then the only explanation is now the power is provided from both cables. 50% from the original cable, 50% from the new one. We can confirm that. I connected this Ubiquiti PoE power adapter to a Ubiquiti PDU. So from the PDU for part 9, I can see, yes, it's connected to E7, right? So the power consumption is 12 watt. Now it makes sense. So the total power consumption from this adapter and this PoE part, the summary is what the E7 is using. So it's more than 20 watt, similar to what we had before enabling the high availability, right? So now the power consumption puzzle has been resolved. As long as you have both PoE++ connections, the system will automatically distribute the power consumption to the 2 sources. Let's look at the confusing situation regarding the data redundancy. From the UniFi network controller, you can see the same confusing situation. See, E7 is connected to Pro Max 24 instead of the 6-port PoE switch. It doesn't make sense because point number 1, the PoE switch has 10 gigabit connection. E7 should take the PoE switch as the preferred switch, right? Point number 2, even from the E7 itself, let me show you again. When it comes to experience, it confirms 10 gigabit. So from the Pro Max switch, there's no way it can get 10 gigabit, right? To resolve the puzzle, I need to SSH into the E7 access point. Okay, I'm in. See the network topology changed. So now the E7 is changed again. So E7 keeps changing the uplink from the PoE switch to the Pro Max and then switch back. So the system is showing the misleading, confusing, contradicting topology. To understand that, from the SSH session to the access point, let me run LLDP CLI. It is the CLI interface for LLDP. You may know LLDP is crucial for the system to construct the network topology. Then let me show the LLDP neighbors. Okay, it shows two neighbors. See, Ethernet 0, the 1 gigabit part, is connected with USW Pro Max 24. Yes, makes sense. And then Ethernet 1, which is the 10 gigabit part, is connected with the PoE switch. Also makes sense. So from LLDP perspective, nothing's wrong. The system clearly understands what's happening, what's the connected neighbors. Because we have two active connections for the access point, the system must decide for a given packet how it should route the packet. So let me check the routing. Run command IP route. Oh, let me exit the LLDP CLI, then run IP route. The default route is to this UniFi gateway, and see the device is BR0. This is the starting point for us to understand what's happening when it comes to the data connection high availability. Just from the device name, it's a bridge. So to understand what's BR0, let me run command BR control, bridge control, show the current bridges. Okay, there's only one bridge defined in the system. It's called BR0. And see STP, it says no. And for interfaces, which are part of BI0, it lists a whole bunch of wireless interfaces, right? I'm not interested to them in this video. I only want to focus on the very first one because the name raises my attention. It's called bound 0. In Linux networking, when we say bound, we either mean it's a primary slave bounding or we mean it's the link aggregation. Because now we are talking about two totally different RJ45 parts. One is 10 gigabit, the other one is 1 gigabit. So I assume this bound 0 is a primary slave configuration. But to confirm that, let me first see whether I can show anything by using the iplink command. Okay, it simply tells me it's up. Nothing's interesting. So then let me see what's the running network information from the operating system level. So I want to see the network bounding current situation for bound 0 device. Oh, let me change the typo. Yes, PROC. Okay, a lot of interesting information. So see the bounding mode is fault tolerance mode, active backup. Let's check these two sections first. It lists all the participating interfaces, so-called slave interfaces. So the first one, Ethernet 0, which is the 1 gigabit one, right? The Ethernet 1 is the 10 gigabit one. Then let's look at this section. It says what's the current primary interface is Ethernet 1. What's Ethernet 1? Is the 10 gigabit one. So now it answers the question, what's the current active data link? Yes, it's 10 gigabit. It makes sense, right? So then the second puzzle has been resolved as well. The so-called high availability when it comes to data link, there's nothing special because E7 runs Linux operating system. It has two physical RJ45 ports. Then the system simply used the Linux built-in bonding functionality, configured a bond zero fault tolerance interface, and at this moment one is primary, the other one is backup. The primary one now is the 10 gigabit connection. So everything makes sense, puzzles resolved. It doesn't answer the confusing fact that the network topology in network controller cannot reflect the correct topology. Most of the time, the E7 will be shown as a child of the Pro Max switch, right? You know what? It can also be explained that the system uses LLDP to construct the topology, and based on what we found from the LLDP CLI from the access point, it shows two parents. Depending on which parent receives the LLDP packet from the access point, the system may show the access point as the child of different parents. So apparently there's something Ubiquiti need to resolve when it comes to LLDP and the Linux primary slave bonding. But it doesn't really bother me at all because from the backend I can easily tell which is the real primary link and which is the real primary parent node. In the remaining part of the video, let me do some testing to see the high availability in action, the most common scenario when it comes to failover. So let me simulate a failure on the primary link, the 10 gigabit one. I will simply remove this cable, which means I will cut not only the 10 gigabit data link, but also one of the PoE++ power supply. Just by removing this blue cable, I will cut two sources, one power, one data, right? So let's see whether the system can recover automatically. More importantly, whether the ongoing transaction, which is the iPerf3 testing I'm doing, whether it will be impacted. That's what I'm really interested to see. Okay, so let me simulate a cable failure. Okay, the link is disabled. And see the current speed. Only for a short 1 second, I see the speed shows 0, and then it's like nothing's happened. The iPerf3 testing still going on. See the transmission speed, now it's changed to about 1 gigabit. It makes sense because now I assume the active data link becomes this green one. And just to confirm that's the case, let me go back to the SSH session. Then run the same command to see the current bond 0 runtime situation. Okay, see what's the difference? Current active slave is Ethernet 0, which is the 1 gigabit port, right? And then see what's the situation for Ethernet 1? Speed unknown, because I already simulated the cable failure. Now this E7 should have a active 1 gigabit link speed. So if we check the E7 status from the network controller, you can see a warning, poor Ethernet link speed. Then from the parent device, see, experience is 1 gigabit. Now if I show the left side PoE adapter's power consumption, I go to the UniFi PDU for this port 9. See, the current power consumption is 20 something watt, right? Which means now this access point is only powered by the left side PoE adapter. Both the data and the power failovers were successful. Okay, perfect. It's a complete success, and the system failed over to the 1 gigabit connection without any intervention. It's completely automatic, right? But there's only one complaint from me. Now the topology becomes really annoying. Still keeps changing back and forth. Okay, now let me move on. So in next testing scenario, what I want to test is, let me cut the link for the green one. At this moment, the high availability is active and I have both the blue and the green links connected. Now let me simulate a failure on the green one. Okay, I have cut the link for the green cable, but from the iPerf 3, you can see it seems nothing's happened. I still see the more than 1 gigabit performance testing, which means it is still using the blue link, which is 10 gigabit, right? We can confirm the active data link from the SSH session. Let me clear screen, then run the same command again to show the bound 0 information. See, the primary device is Ethernet 1, which is the 10 gigabit. And then let's see the situation for Ethernet 0. The MII status is down, speed is down, completely as expected. Again, a success. Before moving on, if we want to check the power consumption for this PoE switch part 3, you can see the current power consumption is 21.5 watt, completely as expected. Okay, now let me move on to the third testing scenario. So this time, let me keep the data link for this 10 gigabit cable. I only want to cut the PoE power supply. And then at the same time, I want to keep the green cable unchanged, which means the expected result is I want the green link to provide power and the blue link to provide data. Let's see whether I can achieve that. Before doing that, let me restore the system setup to the original high availability situation. To simulate this type of PoE failure, let me go to the PoE switch for this part 3. Let me keep the part active, but only switch off the PoE. In this way, the data link should be still active. Apply changes. Then let's see whether the iPerf 3 testing will be impacted. Okay, I have waited a while. It seems the iPerf 3 is not impacted at all, which is good, right? Then to confirm that, let me go back to SSH, then run the same command. Okay, current active link is Ethernet 1, and both Ethernet 0 and Ethernet 1 are up, which means from data link perspective, there's no failure. And then if we check the port 3, see, it doesn't have PoE icon already, which means there's no PoE power from this PoE switch. If we check the PoE adapter's power consumption from the UniFi PDU, we can see the current power consumption is 23.85. So now the E7 access point is completely powered by the PoE adapter, but the data is still going through the 10 gigabit Ethernet cable. Perfect. That's exactly what I want. Now move on to the very last scenario. This time, let me still keep the green link untouched, but for this blue cable, I want to cut the data link, but keep the PoE power. Let's see what will happen. To simulate this type of data link failure, I go to this PoE switch, go to port manager for the port 3. This time, I want to keep the PoE enabled, but I disable this port. So in this way, the blue link will still provide power, but no data. Apply changes. Let's see what will happen for the iPerf 3 testing. Okay, see the data is slowed down for 2 seconds, and then it's back to about 1 gigabit. The system behaves as what I expected. For the last time, let me go back to SSH, run the same command. Currently active interface is Ethernet 0, which is 1 gigabit. And then for Ethernet 1, see the MII status is showing down, okay? But if we check the power consumption for this part 3, you can see the PoE is still enabled and the power consumption is 8.9 watt. So which means the other half is still being provided by the PoE adapter. So the power situation has not been impacted. Only the data is changed. Okay, so after this back and forth 4 scenarios testing, I believe it's very clear. I'm happy with the high availability failover testing. Okay, this is the end of the video. Thanks for watching.